So, good afternoon, and thank you everyone for joining us today for the OptiDrill webinar on sharing the vision, advancing wells with sensor technology and machine learning. I'm Tamana Khan, and I am the dissemination manager for OptiDrill project, and also the senior consultant at Technovative Solutions Limited. OptiDrill project started in 2021, back in and it's a 3-year-long project funded by the European Union's Horizon 2020 grant projects. And very soon we will be celebrating the finishing the second year of this project. OptiDrill project is developing a real-time drilling advisory system for optimizing geothermal drilling operations, utilizing novel sensors and machine learning methods. Today in this webinar, we have 3 OptiDrill partners who will be joining us and presenting to us the vision and progress of OptiDrill's advisory system. After the presentation, we will have a roundtable discussion between the speakers, and we will conclude this webinar with a Q&A session. I would like to inform you that this webinar is recorded for further dissemination purpose, and I would encourage our attendees to write down their questions on the chat for the Q&A session. So now I'm very happy to introduce the speakers for today's session. First, we have Hazel Farndale, who is a business development manager at Geothermal Engineering Limited. Hazel is not only leading the technical reporting, but also identifying, exploring, and planning new geothermal sites across Cornwall, UK, and managing several international research projects. We also have Helen Haraldsdóttir from OnPower. As you already know, that OnPower is one of the largest geothermal power companies in the world. Helen is a project manager in R&D, and she is involved in various national and international geothermal projects where she is working on geothermal energy, corrosion of material for geothermal environment, deep geothermal wells, and focusing on emission reduction and waste on value applications within geothermal application. Last but not least, I would like to introduce Kevin Mallin, the technical manager of OptiDrill and also the managing director of GeoLorn Limited. Kevin has over 40 years of drilling experience across a broad spectrum of industries from oil and gas through deep geothermal. Kevin's organization, GeoLorn, has managed several deep drilling projects, including the Science Central Geothermal Well in Newcastle, UK, Instinct Energy in Namibia, SD1 Geothermal Wells, Finland, etc. So without further ado, I would like to ask Kevin to lead the presentation. So Kevin, the floor is yours.
Thank you, Tamana. That's a wonderful introduction. It reminded me, it's the trouble with being old, you forget what you have done. So thank you for that, Tamana. This presentation, as and many of you know me, my presentations, I like to make them thought-provoking. So with sharing the vision, really, we want to hear back from you as well about what we're doing currently in OptiDrill and where you think we may need to go in the future. We are looking primarily at deep geothermal wells at the moment, but as we all know, we're going to have to go deeper and deeper into the subsurface for the future, especially around climate change, so decarbonisation, and I'm sure Helen later will talk about a little bit about carb fix and putting carbon dioxide back in the ground. I just want to share with you an amazing fact that I heard yesterday, that there are 10,000 scientists currently gathering together in Montreal for the UN Biodiversity Conference. And I'm thinking, well, all of those 10,000 scientists will be human beings, and they're going to start looking at how they can protect nature. I did think and wonder, if we released 5,000 saltwater crocodiles into the conference, who would win? Would it be nature or would it be the scientists? So I just want to leave that thought with you. Okay. If we can get the slides to go, here we go. Next slide. I'm going to call upon a few sort of cliches, I think, in this presentation. Isaac Newton, as we all know, he said he could see further by standing on the shoulders of giants, and I think this is probably one of the sort of founding ethos of the OptiDrill project. When you think of how many deep wells have been drilled, shallow wells, just small holes for putting fence posts in, there's a huge amount of information out there. Not all of them being drilled the same. Some will be drilled in a similar fashion, but each individual well that gets drilled has certain nuances that we need to try and capture and really share amongst ourselves as an industry and as a, and the scientific bodies out there, try to understand how we can make this thing better. And we use the word optimize, but we have to be sure that when we do optimize, that we don't end up compromising things. So it's which is why this today's sort of hour-long speech, I hope will, result in 10 hours or 20 hours of emails back and forth between ourselves, how we can get these things to be better. The interesting thing about this Newton's cradle, and I thought about it when I was sort of rehearsing my sort of talk earlier this morning, is that only the walls on the left, on the outside, actually move. The rest in the middle don't. So I wonder if that's a metaphor for life, that we get stuck in the middle, and it's only those things on the extremes that actually change things. So again, I want to be thought-provoking. As we all know, seeing is believing. If you can see something, it's much easier to understand what it is. Just looking up at the stars, you think, okay, I can see stars. And the little chap on the right, he's looking up into space and thinking he can fly. One of the things I do, and we do quite a lot of driller training, and trying to get people to understand what drilling is all about. And one of the questions I often ask, and usually start sort of the sort of teaching things with, I ask people to look out the window and tell me what's happening 5 kilometers away. And most people look out the window and have no idea. And why should they? So but then they think, well, 5 kilometers, that's roughly where the supermarket is, or the pub, or the fish and chip shop. So they start to build a picture in their head. But if you imagine, when we start to drill deep wells, we sit our rig up on the top and we want to go 5 kilometers deep into the Earth's crust, it's pretty blind. We can use information from other wells, but do we actually use it in a tangible fashion? Do we collect all that information, and do we use it to the best of our capabilities? So this is what I think in the OptiDrill, and we got some incredibly clever people involved in this project, and not just involved in the project, but other people who've already gone before us in this sort of technology sector, that we're starting to build the picture. So once we say sharing the vision, and that's why I sort of picked on that sort of phraseology, we want to share this vision, and it's very important that you know, there's the information that we all keep up in our heads, or we write in our diaries, we keep in spreadsheets. We need to share that amongst ourselves if we're going to have a successful, in particular, a successful geothermal industry, because, as everyone knows, you know, everybody says at least 50% of the cost of a deep geothermal project is associated with drilling. How can we, you know, how can we start to rationalize that cost? How can we sort of lower that cost? And so understanding what the problems are is going to help us find the solutions. And sometimes, you know, we may create problems that don't actually exist, and you know, we spend a lot of time trying to solve problems that aren't really of a great sort of influence on what we're actually trying to do. But the drillers amongst you, this is in fact, this is actually from, I think this one is from Namibia, where we drilled. We were looking for, in fact, shale gas at the time, when shale gas was still in fashion. It no longer is, and quite rightly so. Well, certainly not in the UK. America's making a huge amount of money at the moment because of the crisis that we have in the globe about, you know, gas shortages. If every time you went to drill a well, you had all the core, the complete strata from top to bottom, making, you know, drilling your new production well would be very straightforward. But we could find, if that's offset, that cored well was offset by maybe 50 meters, we may find that we're not quite in the same lithologies. And sometimes when you go with preconceived ideals of what you're going to drill through, that's when the problems start to occur, because you set yourself up for, you know, a particular drilling method. That particular drilling method may not be the correct one or the most optimal one for drilling your wells. So again, what OptiDrill is trying to do, and we're making huge bounds in this, is we're collecting as much data as we can. We're looking at all the old daily drilling reports that are some handwritten, some kept in Excel spreadsheets, some on the IADC forms, and we're actually analysing those in a sort of a good old analog process. We're actually putting them into like a Gantt chart to show when the holes were drilling, when they're actually the bits on bottom and making further hole, and when it's not. And I think that's really with the machine learning guys particularly at the BGS and the British Geological Survey and the Fraunhofer Institute in Germany, which are two of our major partners. That, you know, we're starting to build a picture, and we're starting to see things from these pictures that help us optimize the drilling process. Now, when we get onto the this is the machine learning, and you know, it's part of our everyday lives now, and there's plenty of people, I'm sure, on this call who understand huge amounts about machine learning and the development of artificial intelligence, etc. When you actually think about it and you break it down into what I call my understanding of things, it's basically having lots and lots and lots and lots of very clever people all sharing their knowledge and expertise, and then we're decanting that into a small area. So those 10,000 people, let's say, are all held within a small pod of information. And I think this is one of the critical things about the machine learning that we're utilising for the OptiDrill process, that old drillers, young drillers, new drillers, people who understand subsurface, and geologists, geophysicists, we're trying to encapsulate all that knowledge and the skills that these people have, and we're trying to encapsulate it into a system that when we're drilling, unlike with someone just taking over and not involving you in the process, it's going to tap you on the shoulder and say, have you thought about this? Maybe you should be thinking this way. So I think it's something that's very important, and I'll go on to the automation bit in a minute, but I think we mustn't let the machine learning be the end game. It's really our stepping stone to the stars. So the machine learning is going to help us in the seeing section of what we're trying to do. And artificial intelligence, I wish I had some, I do wish I had some artificial intelligence. And I often think about drillers. There are drillers who drill on instinct, and there's some very intelligent drillers. And if you could mold those people together, we would have an incredibly vibrant and low-cost industry. But at the moment, there's all sorts of issues, problems with bit selection. Is it the right bit selection? Fluid, everything you can imagine that's going to go on down that well. There's going to be someone who has a different opinion to yours, and rightly so, because drilling is part science and it's part art, and it's managing bringing that art and science together. I believe is going to hugely change how we get the cost of deep geothermal wells down. And I'm sure you all know there's some incredible technologies out there, and some of them are sort of reaching commercial stage. Some are still being looked at, with laser technology and plasma, microwave drilling, electron pulse drilling. There's all sorts of things going on out there. But when we actually stop and think, we've been breaking rocks for thousands upon thousands of years. So, what are we trying to do with our technology in terms of breaking things so we can actually make holes in the ground to access resources? We just got to make sure we get on top and understand what the end game is, and not just thinking, we got to drill quickly. We got to make sure that the well that we drill is usable. I just picked these things because obviously data is at the moment, everybody wants data. Data is the new sort of currency for anything, and people are building huge data banks, and they build companies just based on data. So if you imagine how many wells that are drilled, and you don't have to look at the numbers there, but it's quite a large number of wells that get drilled every year. Everyone will have its own fingerprint, and so we want to try and encapsulate all that information. But at the same time, we've got to make sure that the data that we use is sense checked, because and I often use it. It isn't a joke from the 1970s, but when you look at statistics, 10% of road accidents are caused by drivers who have been drinking or under the influence of other narcotics, which means 90% are caused by people who are not under the influence of alcohol or narcotics. So, you've got to then think, well, it's got to be safer to be drunk, because it's a much lower risk of you not having an accident. But we know that's not how statistics works. So when we start to look at data, we have to really understand what the data means. And yeah, and I'm paraphrasing our old friend Samuel Taylor Coleridge there, from the Rime of the Ancient Mariner. There is huge amounts of data out there, and human beings don't have the capability to encapsulate all that. So machine learning, feeding this data in from decades and decades of drilling, has got to be beneficial for advising future developments and future ways of drilling things. And there will be huge amounts of data that gets lost. But if we can encapsulate as much data as we can from previous drilled wells, and when we talk to Helen and Hazel just a bit later on, they drill in completely different environments. Helen's in the sort of volcanics in Iceland, and Hazel's down in beautiful southwest of the United Kingdom, and I am sponsored by the Cornwall Tourist Board. In the hard granite, so there's a complete contrast. Yet quite often they're being drilled with the same methodology. So we need to start thinking: are we doing things correctly? Let's look at the data. Let the machine learning help us rapidly understand how we could have done something better, more optimized, to use the word. And at the end of the day, if you drill optimally, you're going to reduce the cost. Sometimes we get caught up with rate of penetration. We've got to get the bit into the ground as quickly as possible. That's not always the best way. We've got to look at the rate of progress. So understanding how we can get things to go quicker, overall, is very important. That's just, I just want to show you there. I mean, it doesn't really mean a great deal, other than those are all the sorts of wells that got drilled, that's just the US. So you can imagine how much data is sort of spewed out of these wells. It doesn't get encapsulated, and you'll get, a shale gas driller from, West Virginia, and you move him down into Pennsylvania, and the ground will be different, and he won't know what to do. They just don't drill optimally, and so the OptiDrill project, and I will call it project. What we're trying to do is change the way things get done, and we're a sister project to the GeoDrill, and I'm sure lots of you on today's call listened to my good friend and colleague Volker talk about geodrilling a couple of weeks ago. And what we're doing there is, with the sort of holistic drilling system, OptiDrill it's going on to the next stage of taking all the data, and we can drill with anybody's downhole tools. And I think Ronald, who's on the call from Radial Drilling, very specialized drilling technology, but we're developing a system that will work for Ronald's tools to make his system much more optimal. And we can talk about down the hole hammers, air hammers, fluid hammers, tricone bits, PDC bits, and there's some and a big shout out to the guys from Zero Lab who are on the call today, because they're doing some amazing things with PDC bits now. So these things are all starting to work together, and it's quite important that as an industry, that we share our experiences, we share our knowledge, and whilst each of us needs a commercial advantage to make sure that we stay in business, at the end of the day, we've got to make sure that we have a business to stay in. So I think sharing some of these things is vitally important. Your IP, keep it to yourselves. You know, that's your raison d'etre and how you're going to stay focused. But at the same time, there's lots of information that we need to share amongst ourselves. And I know the OSDU platform are collecting vast amounts of data as well. So and I will say the Norwegian database for all the wells they've drilled offshore is just colossally important to us, and as is the BGS one as well here in the UK. Right, bit of science now, which is probably not my strong forte. Being a driller, you know, I sort of count to 21 if I hadn't lost a finger. What we're trying to do here is build all this, take all this information, and using the machine learning, there's some complex algorithms and coding, and Henning from Fraunhofer, and they've got a couple of chaps in the BGS. I mean, they're writing some incredible software that understands and rationalizes all these things, whereas, you know, I'm still into spreadsheets. So I draw everything up and I like to see it. But going forwards, once we get this and the sort of sensors and real-time data transfer from the bit and comparing maybe 10, 20,000 wells that have already previously been drilled and have seen similar sort of signal patterns, then, you know, we're going to be streets ahead in terms of what is capable and what we can do with these things. And anybody on the call today who's really interested in the machine learning side and the artificial intelligence side, etc., drop me a line, and, you know, I'll introduce you to the team who are, you know, the really focused on the machine learning and the AI side of this project. There we are. So all those squiggly lines, you know, decision-making trees or whatever we like to call them. At the far right there is the rate of progress or rate of penetration, however you want to look at it. All that clever thing. What I'm interested in is that little red ball on the right. You know, the green one's on the left, I can control its surface. The one on the right is controlled by everything else that goes on in between. So, and as they say, you can only worry about the things that you can control. So with the machine learning in particular and the artificial intelligence starting to build and help old fellas like me and new younger people coming into our industry, and we need to attract them into our industry because we're going to have a hiatus soon of not many skilled young people coming into the drilling industry, and it's quite important that we do. So things like this will entice younger people into our industry, I hope. I sincerely hope. This is a burning question. For me, you know, the difference between should we automate, you know, so and there's a few statements there, you can read them out for yourself. I'm not going to read them to you, but is it better to advise someone from what you've learned, or just take that decision away from them and allow a machine just to do it all? Will our industry get any better? I don't think so. I really don't think so. I think we need to have this nice blend, automate those things that people don't like doing, and that's like cleaning threads before we screw them together, lifting drill pipes, taking people out of harm's way. But once I think once the tools are in the ground and making a hole, I think that needs a human touch, because we're getting into that sort of artistic field, making sure that we're getting the best out of the drill tools in the hole. And we quite often may not have the right drilling tool in the hole, but with a good driller, he will do his very best to optimize, what he can get out of the tool. So I'm hoping in the questions in the Q&A, we'll get some talk around this, what people think about, should we have an advisory system, or should we have a system that takes it to full automation? I've stated my case. I think we should have advisory systems. This is, and probably some people have actually seen this before. It's a similar one that's included in the GeoDrill presentation. The people from PVI, which is Precision Varionics International, they're I mean, just amazingly clever people. And my good friend Pufinji, he likes to use curly brackets whenever he talks to me. He has equations that go on, over several pages. But at the end of the day, what he's doing, he's using sensors, and those sensors will pick up certain things that as we're drilling. And the nice thing about, and I think this is very important, that when Pufinji and his team from PVI joined us, they didn't really know anything about drilling. They knew huge amounts of things about sensors. So, they weren't constrained by the thought processes, a driller's going to want to know this. They started to look at the sensors. How could they get sensors, and what could those sensors do? And I think that's been very important. This is actually a slightly old version. We got a super duper new version of the sensor, what we're calling a sensor string, which we think is going to be incredibly groundbreaking, to use a drilling term. This is going to transmit data in real time. We're going to have especially wired drill pipe, which is still being developed. We had hoped to have it ready sooner than it is, but it is proving a little bit of a challenge, not because it's difficult to do the actual wiring of drill pipe, but it's difficult to do wiring a drill pipe that will survive drillers, because as we all know, drillers just like to break things. That's our whole aim in life, is just to break things. So, including our bank balances. So I'm just that's the sort of a brief wrap up of where we are and why we're doing what we are doing in OptiDrill. I'm just going to pass over to Hazel from Geothermal Engineering Limited, who have been, and they're involved in our project, and they provided some incredibly useful data for our machine learning. So I'll just pass it over to you, Hazel, and just let me know when you want me to advance the slide.
Thanks, Kevin. Appreciate it. Yeah, I won't take up too much of your time. I appreciate you inviting me here to join you. But a little bit about, a bit of context about what we do with geothermal engineering down in Cornwall, and then why we're therefore excited about what comes out of the OptiDrill project. So we are the owners, operators, developers of the United Downs Deep Geothermal Project, which will be the UK's first geothermal power generation project. So the whole point of what we're doing down here is to prove that commercial geothermal electricity production is possible here in the UK, because it's not something that's been possible to date. It's something that the expensive drilling costs that we've heard about have often been prohibitive of. So it's exciting for us to be able to see a project and hopefully an outcome that will help increase efficiencies and help improve the small margins that there are in an environment like we're in. So to date, we drilled in 2019 roughly, and we drilled for about 7 months. You see the image on the left here is a lovely old engine house down in the bottom left corner, which is the sort of the legacy of the Cornish mining heritage. And then we've got the brand new rig. This was about 50 odd meters tall in the background, and that was really exciting for us to have that here. Of course, it was there was a long run up to this project, you know, raising funding and just finding a site as well took us around a decade. So it's something we've been aiming to do for a long time, the royal we, of course. Thankfully, all drilling went to plan, more or less, and we were able to test throughout 2020 and 2021. So the final phase of well testing happened in July 2021. That's where we got this image in the middle here, and it was the UK's first geothermal steam, which was frankly a bit of a PR stunt to get photos like this. It's you know, it's really exciting for us. It proves, hey, look, guys, we do have geothermal power. Isn't that great? And it really showed off geothermal. Because on the right here, you've then got an image of what our site roughly looks like today, with the 2 wellheads awaiting the power plant delivery. And frankly, the site is pretty underwhelming when you're just looking at these 2 wellheads. Of course, that's part of the beauty of geothermal, is that it is underwhelming. It is difficult to see. There's not that much at the surface. But when you're trying to raise funding, when you're trying to get people excited, sometimes you need the money shot in the middle of that steam. Next slide, please, Kevin. So just a bit of the context of why we're drilling down here in Cornwall. It has the granite body, a really large batholith that extends from Dartmoor in Devon in the east all the way out west to the Isles of Scilly off of this map here on the left. So it's this huge granite body. We don't actually know how deep it is. There's lots of people sort of hypothesizing, trying to get gravity measurements and trying to understand whether it is, you know, 10 kilometers or even much deeper. But it's that, because it's radiogenic, that gives us this huge amount of heat. So there's plenty of places in the UK you could dig down and get some good temperatures, get some heating systems from, but Cornwall really was the low-hanging fruit. It's the obvious place to try and get electricity generation. So we have the United Downs project that we run, and then there's also now Eden Geothermal who have drilled a single well to date, and I believe they hope to drill a second in the coming years. So what we've done is we've drilled a very deep production well down to 5 kilometres, and then we've got a re-injection well down to 2.3 kilometres. We've drilled into a natural fracture zone, which gives us permeability that you wouldn't naturally have in Cornwall. The problem with drilling so deep, I mean, as you've heard from Kevin, is there's very little data out there. It's very unknown. You can map these fault zones at the coastline in Cornwall, but really once you start going inland, there's almost nothing. So, you know, I hate to say we're drilling blind, but it's very difficult to prove what's down there. So understanding the lithology, understanding those fault zones is incredibly difficult. I'm a geologist by background, not a driller, and you know, frankly, there's not that much we can do. I think everyone would agree. We can try and do geophysical surveys at the surface. Some have been done, but identifying a water-filled, quite narrow fault zone in a large granite body that is fairly homogeneous is difficult. So being able to have a sort of real-time look at what's happening whilst we're drilling, built off these decades of data that Kevin has spoken about, is quite exciting. You know, being able to understand what we need to do when there are issues with the torque while we're drilling, when there's issues with trying to drill directionally. You know, sometimes these wells can go all over the place in trying to get in the direction they want to go. We had a big, like a massive quartz boulder whilst drilling. No way you could have predicted that, but trying to understand how to overcome those sorts of obstructions will be very valuable. And as Kevin said, you know, if we can reduce these inefficiencies of drilling, you know, we did fairly well. We did have an ROP that was decent, but there's always room for improvement. And there's plenty of lessons learned that we hope to move forward into many future sites across Cornwall. Ultimately improve our costs and make it more attractive to investors. That's the bottom line. Next slide, please, Kevin.
Well, Hazel, I've actually volunteered you to give a brief introduction to WING, which is Women in Geothermal. So
no problem. Very happy.
I've got a few slides for you. I hope it didn't take you by surprise, but here we go.
Not a problem. Yeah, I think it's a great platform here just to talk a little bit about women in geothermal or WING. It is a global community, but the UK chapter have become more and more active over the lifetime of the OptiDrill project over the last couple of years. So yeah, very happy to share what the community has been doing. Next slide, please. So it's the largest international geothermal society. It's not just women, even though the name suggests it could be. So yes, we have over 2,800 members, with 30% of which are male, across 86 countries in the world. And there are 34 individual chapters, of which the UK is one. Next slide, please, Kevin. So WING over the last few years, you can see here it was relaunched at the end of 2019. I would say it took a little bit of time to get going into 2020, but really since then they've really worked hard. I can take no credit for this, just throwing it out there. The committee behind it has worked really hard to put together lots of events, both sort of for socialising, for sort of career awareness, and for sharing as well amongst the community. So they instigated in 2021 sort of yearly themes. We had the role of geothermal in the oil and gas transition was the theme for 2021, and then 2022 was the role of geothermal in society. So with those sort of underlying themes, there were lots of talks they put out there. They had these things called Wednesdays with WING, you can see, which was the last Wednesday of every month, which is still ongoing. And they'd invite people like myself who are part of the geothermal community, both in the UK and from abroad, and to come and talk about what we're doing and just invite discussion and sort of show students and people in industry alike what's out there and how exciting it is that the geothermal industry is growing here in the UK. So there's a lot of student engagement. There's lots of sort of highlighting personal journeys, and it's been really exciting to see. So what else have we got here? Oh yes, there's a newsletter which comes out, I think it's 3 times a year, and there is a mentoring program as well. So members of the committee who are in industry, perhaps have been working in geothermal for multiple years, can take on students and talk to them about, you know, their own journey into geothermal. Next slide, please, Kevin. I think this is the last one, and just talk a little bit about future initiatives as well. So they're looking at doing a sort of blog series, a day in the life of women in geothermal. So that'll be promoting geothermal as a career path of women from all walks of life, and doing a vlog series. A video log, that's what it is. I'm sorry, I don't even know what these things mean sometimes. So yeah, Geothermal 101. So that's again bringing in much younger as well, looking at school children and introducing them to geothermal. Which is something that's so important. We certainly know from an industry perspective how important it is to get the local communities of whatever age involved in these projects. So it's just another arm of that, getting out and educating people. They're also looking to do a podcast and hopefully a conference as well in the future. So there's lots of events coming up, or hopefully we'll tie in with that with OptiDrill as well. And then I think there's a final slide, Kevin, just to show a few wonderful pictures of various people from WING out and about enjoying themselves. So you've got the classic geologists out in the mud, of course, as well as plenty of attending conferences and the like. So yeah, thank you for letting me chat about it.
And there is a prize for someone who spots the non-female geologist in the pictures. But I think what is important to share the WING, the introduction to WING is, you know, this is how data gets disseminated. You know, quite often, you know, Lucy, who's up in the top left, who was one of the project geologists for United Downs, you know, shares information, you know, and this is how we build our data centers. So human interaction, I think, is vitally important for our industry. You know, and these seminars and the podcasts and the sort of meetings, they are very important. And just going back to with the start in the 10,000 scientists gathered together in Montreal, you know, they obviously have an important part to play in how things move forwards. So so thanks, Hazel, for sharing those.
Pleasure.
Right, I think we can have a little bit of a round table discussion now. We're probably a bit behind time because I'm very conscious I want to get into the Q&A. because that's the whole thing. So we will have some. Tamana, have we got lots and lots of questions? Because I can't see them, unfortunately.
Well, I have 4 questions from some of my colleagues here, but I don't see anything in the chat. So I would really encourage you to put your questions here on the chat. And if you would like to speak, then please raise your hands so that we can enable your microphone. Thank you.
Either that, I've done such a good job that I've answered everybody's hesitant questions. But I don't believe that for an instant. I'm sure there must be questions, and lots of people know me, so I'm sure I'll get inundated with emails. And by all means, please email, because you know, sometimes these things are not the places to ask questions, because you sit back and you think, and then, you know, sort of 10 minutes later, you think, oh yeah, I'd like to ask that. So, but anyway, I'd like to now just introduce Helen as well from OnPower up there in Iceland. And I thought I'd stop sharing. You should be able to see us all. He says. There we are, and hopefully Helen's finished her lunch, because she rushed here because the lunch service was a bit slow in Iceland today. So hopefully Helen's finished her lunch. As Tamana said earlier, Helen's one of the sort of R&D project managers with OnPower. And what I'd like to know, you know, obviously I'm the sort of technical manager of the OptiDrill project, but at the end of the day, you know, of all the work that we're doing, what do you see as the sort of main takeaways for you guys in terms of, you know, collating all this data and helping you with your drilling? So I'll ask you first, Helen, whilst Hazel catches her breath.
Well, thank you. Thank both of you for a very informative talk. So as you mentioned, we're looking at both the machine learning part and the sensor part, and anything that can assist the course drillers to make the drilling procedure easier, more effective, quicker. That's all very relevant and interesting to us. Of course, we're not drilling our wells ourselves. We have Iceland Drilling that takes care of that. They're very skilled drillers. They've got a lot of information and knowledge on how to drill in our area and other areas as well. So they know a lot about this, but it's my feeling that more information is always better, and especially when you can get something that can help you, you know, support you and all that. So all kinds of development, I always see that as a positive thing. And that's also why we participate in these projects and all that, because we want to make this more accessible, easier. You can have it, then you can make geothermal more accessible worldwide as well, because you'll have better tools, you can make it cheaper and all that. So both, to answer your question then, Kevin, so both the sensors and the machine learning part are both very interesting to us, as I say, as it is to you and everyone else, I'm sure, as well.
Yeah, because obviously, I mean, drilling in Iceland has some fairly unique sort of parameters, you know, because as everybody knows, the islands constantly sort of erupt, and so you can start drilling on one day, and then when you get back there the next day, the whole island's changed. So, you know, that sort of information, and you know, you may find that some of the things that we do drilling in hydrothermal basins or in sedimentary basins, that can be beneficial to you, and vice versa. Some of the things that you do, which is why again we're trying to encapsulate this in the OptiDrill project. So thanks for that, Helen. And Hazel.
Yeah, I mean, both sides are super important. I think that having them both together is really key. I guess certainly whilst we have drillers that come in, I think we work so closely with our own internal drilling team. I think seeing the sensors go down would be really exciting. So I'm looking forward to seeing what comes out of those the most.
I will add as well, when I first spoke to Ryan, who's managing director of Geothermal Engineering, he said, if it makes my drilling cheaper, I'm in. So
that is the bottom line, of course. Yeah. So we can beat
Exactly,
about the bush, but you know, especially as a small company where the margins are tiny, you know, every penny counts.
yeah, that's good. So and for future developments, where do you think that we need to be going with the sensors in terms of where we currently are with your drilling, say in the granites in Cornwall, or in this sort of pyroclastics that you have in Iceland, etc.? Where would you like to see the development of the sensors? What would be the most important things? Would it be, you know, rock hardness, you know, porosity of the rock, temperature, and anything that we can actually build into the sensors going forwards and analyze in real time? Where would the most benefit for your particular types of drilling come from?
I think off the top of my head, and of the three particularly listed, the hardness would be incredibly interesting to understand more about that. And you have zones of kaolinization, of alteration within the granite, so you do get these vast changes that are incredibly difficult to predict. And because it is such hard rock in the first place, I think it can be a challenging environment to drill in. So I think that would be my number one.
Well, from my side, I'm not an experienced driller. I know very little of the drilling procedure itself, so I couldn't quite tell you exactly what would be most important to them. But of course, the combination of all these is important, and we are looking at, for instance, also temperature and all that, heat, because we're also interested in higher temperature areas as well, such as the IDGP projects that we have. So we're all these different aspects, of course, play into one another. But
Yeah. And I think one of the key things I think we're going to see as well as we go deeper, I mean, currently, you know, if you're using mud pulse technology, you know, it takes a long time for some of the information to come back to the surface. So there's a big lag time. And as Hazel sort of intimated there, that those sudden changes can cause you sort of all sorts of problems. So we're working on some technology now where we think, you know, we'll be able to predict much more quickly before you get into those situations. And you know, as a driller, I mean, it's great. You know, if you don't, it's like walking down a road. If you don't fall down a pothole, you're not going to break your leg. So you know, that seeing is believing is very important to us. So so thanks for that. I mean, those are the sorts of things that the feedback that we need, and why, you know, we're super happy that you're involved in our project, because, you know, we need that real live, this is what I need. You know, there's no point in developing something that has no particular use to anyone. So it's a very much a hands-on approach to what we're trying to do. So have you got any questions?
Yes, I have. So it's from Taylor, and it's a burning question. All of us have that question actually. As a result of Brexit, will funding for UK geothermal projects be adversely affected? So Kevin, what do you think?
But we're going down a really political route now, aren't we? As far as I know, there's an agreement about to be in place where we can cooperate, and I think it's the cooperation, is not so much the cash or the money, it's being able to cooperate with people such as Helen and our friends in Fraunhofer, our friends up in Norway, Sweden, wherever they sit within Europe. It's being able to physically cooperate with them. I'm sure our government in the UK will provide match funding, as Switzerland does at the moment. You know, Switzerland, they're involved in projects and they match fund. But I think the key point to me after Brexit is we don't lose all our friends. You know, we're still basically the drilling community. You know, although we may not be within the European Union anymore, we're still on the same planet. And I think it's vitally important that we don't lose that impetus of work that's been done, and the same with the guys out in the US there with, you know, the Forge project. You know, they're doing some incredibly forward-thinking things, and you know, sharing all that. And as again, it's not just the money, and I'm hugely grateful for what the EU have done for our geothermal industry, amongst, you know, other decarbonizations. It's very important that we don't lose that friendship.
Yeah. Thank you, Kevin. Hazel, would you like to comment on this?
Yeah, just to reiterate that, I mean, the Horizon Europe funding programme, we are still able to get research projects through at the moment. We were involved in a couple more recently since Brexit, and Kevin's right, Innovate UK, sorry, do promise the funding, they guarantee that you will get it. How our association with Europe for those funding body moves forwards, obviously they're very hopeful, but it seems to be going incredibly slowly. It does mean there's a huge amount more admin burden, I must admit. You know, we both have to do the whole European application and then an Innovate application as well, and reporting for both as well. So it's not without its difficulties. In terms of funding of geothermal projects in general, we haven't noticed a big change. There's difficulties in procurement, but in terms of funding, it's still possible.
Thank you. So we have a direct question to Helen. So it's from Hi. Are the IDDP3 drilling using diesel-powered or electric-powered drilling? So Hi, I have also enabled the microphone for you. So if you unmute yourself.
Yeah, I'm just wondering, you know, that do you have can you hear me?
Yes, we can hear you.
Yeah, I'm just want to know about the, you know, the diesel powered. Are you still using for IDDP project for drilling power, diesel powered drilling or electric powered drilling?
Well, I myself I'm not. We don't take care of drilling our wells, so I'm not quite sure, but I'm pretty sure it's electrical. But you don't quote me on that.
Okay, no,
but I know they've had
no,
trouble when
yeah,
it comes to electricity falling
I
out.
understand.
Then the drill has been out. So I'm pretty sure it's at least run by that, partially, if not completely. So.
Okay, thank you.
Thank you. We have another question. Can you please discuss whether the OptiDrill solution will be suitable for a specific type of drilling, for example, rotary drilling? So the question is whether the OptiDrill advisory system solution will be a drilling agnostic solution or not.
Yes, no, it will be agnostic, and that's what we're trying to do. We're actually working with all sorts of different drilling tools. You know, the way that certain bits engage with the rock at the bottom of the hole. Obviously, rotary drilling has different sort of signal parameters that down the hole hammers have. One of the things that people talk about is, you know, torque and drag in certain methods of drilling. With you know, down the hole hammer drilling, we see a lot less of that because of bit weights, etc. But we have a different, you know, shock wave interactions between the rock and the bits. So yes, I mean that is our goal, to have it work with anybody's drilling tools, be they PDC, these are on some very advanced PDC cutter bits, through to basic old, you know, 1930s tricones. You know, we want it to be working with everything, and that's why when a lot of the data that we're inputting has come from age-old, and when I say age-old stuff, from the 1970s, and through to very modern drilling, which is such as Hazel's and Helen's, you know, which are, I mean, they're sort of hot off the press, you know, drilling projects. So no, we want to make it work with everything. There's going to be obviously some drilling technologies that won't benefit from it, and those are going to be the non-mechanical type of drilling with the lasers and plasma and EPB. it remains to be seen where we can add value to that. But at the moment, we'd like to think that all the current drilling technologies that are making commercial holes in the ground will benefit from OptiDrill.
Thank you, Kevin. Hazel, there's a question for you. Will the drilling challenges at the Penhallow site be similar to those seen at United Downs? Unpredictable and very hard lithology when is this well scheduled to be drilled?
Broadly, the challenges will be similar. Yes, you're still drilling through granite for a lot of it. There will be some unique challenges because the granite is a bit deeper at the Penhallow site, which is, we just got planning permission for the site, which is just a bit further east in Cornwall. And so that will come with, you know, we have to understand what the overburden is and what challenges are associated with that a little more, because we only had a few hundred meters of that at United Downs. In terms of timescale, I mean, that's it's a little bit as long as a piece of string sort of question. There are all sorts of things tying in terms of procuring drill pipe and the drill rig. I mean, we compete as an industry with the oil and gas industry, as everyone knows. So getting a rig, particularly as a small company, is challenging. So, you know, we could be waiting a year for that quite easily. So the aim would be 2024. For drilling of the first well. We have site preparation for that, of course, but we'll see how procurement goes.
Thank you, Hazel. So we are almost at the end of our webinar, and I don't see any other questions. So thank you everyone for your question and comments. And please feel free to let us know if you have further questions. So in the chat, I have given Kevin's email address and also our email address, info@optidrill.eu. So I hope to hear from you soon. And thank you, Kevin. Thank you, Hazel, and thank you, Helen.
And we do want feedback. All you people out there who taking the time, and thank you for taking the time today to listen. We want to hear from you, because, as we say, we want to make sure that what we develop in OptiDrill works for all of us. You know, so everybody on the call today, they're going to have their particular challenges. We want to be able to meet those challenges through the machine learning and the artificial intelligence approach. So, and again, thanks to everyone for tuning in. So pubs are open now. It's Friday.
Wonderful. Thank you.
Okay. Oh, and just one last thing, just to Helen. Helen's leaving for a year's maternity leave, so just a big congratulations to Helen, and hope to see you back in 366 days, Helen.
I'll probably tune in before then. Too interesting a project to stay away from that.
Yeah, so. We don't want to lose people like you, Helen. I definitely don't want to lose people like you. So. Okay, everyone.
Okay.
Thank you.
Thank you very much.
Bye-bye.
Thank you.
Thank you. Bye.
Have a good weekend, everyone. Bye.